So for aggregate stability, we are going to go ahead and demonstrate 3 different methods. And again, those methods are described in the question mark text. We'll start with the strainer method. And with the strainer method, what we're going to do is we're going to take some soil that we've broken down into BB-sized or a little bit larger PEDs that we're going to pour into a strainer. And then we're going to set those in a bowl of water and let them sit there for about a minute. And basically, if you need to, you might need to mix them in a little bit, get them down into the water. And after they've sat there for about a minute, we're going to take that and we're going to flip it over onto a board or a flat stone. Back of a clipboard works. And we're going to observe what we see there. If we had seen that all those PEDs were still looking like they did when we put them in the water, that's pretty darn good soil structure. If all we'd seen is a mass of mud, not so good. What we've got here is something in between. Some of those PEDs held together pretty well, but there's still quite a bit that dispersed. So it's an intermediate level of aggregate stability. The next protocol is similar, and that's the cylinder method. But in this case, what we're going to do is take a PED about the size of a golf ball. We're going to put it in that same sieve, and we're going to set it in water. And we're going to leave it there for 5 minutes. So we'll leave that there for a little while. And while we're waiting for that, I'm just going to briefly show you the third method, which is the soil quality test kit. And with this one, it's a little bit more accurate, a little more precise. Takes a little bit longer, but you get a better sense for your field. You're going to want to go and get very small PEDs, about 1/4 inch in diameter, about 18 of them, scattered from around your field. Put each one in here, and then you're going to lower it slowly into water that you've got in the other box. It's good to use deionized water, distilled water if you can. You get slightly better results that way. And after about 5 minutes again, you're actually going to sieve them up and down, okay? And 5 times. And then you're going to rate it based on this scale that's on the top of the box. And these boxes can be purchased, but you can also just make one yourself. This is just aluminum window screen in the bottom here. And you can get the instructions online, and there are full instructional videos for this method also on the Land PKS website. So after about 5 minutes, I'm going to take a look at this PED, and I'm going to look at the water. And what I see is that actually that PED stayed together pretty well. That's a good sign after 5 minutes. But what I'm going to do now is I'm going to take that PED and I'm going to break it apart. And I can't actually break that PED apart. And there's a reason for that. And the reason for that is that the water hasn't even penetrated into the PED. That's how degraded that soil is. So there was enough clay in organic matter in there that it basically is holding the soil and preventing it from completely dispersing. And we saw that in the previous test. But the reality is that soil is so compacted and that there really aren't any aggregates. It's just one massive brick of soil. So again, when you're doing the cylinder method, you not only want to look at what the water looks like and what it looked like in there, but you want to make sure you break it apart. Just be careful if you have to use a knife like I did. So again, 3 methods. They'll all work. If you're going to do repeated monitoring over time, you're probably going to want to use something more like a test kit or a lab measurement of aggregate stability. But if you're just trying to figure out if your soil actually has some aggregation, any one of these methods will give you a sense of that.